आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़, विज्ञान की आवाज़, की आवाज़।
A big hello to all our listeners. Welcome to an enriching podcast series, Vigyan Ki Awaaz. This podcast series focuses on STEM popularization, science, technology, engineering, mathematics, and medicine. Dear listeners, welcome back to Vigyan Ki Awaaz, an initiative to promote STEM, science, technology, engineering, medicine, and mathematics. Taking ahead the journey, we are bringing to you yet another enriching conversation with another eminent guest in the field of science and technology.
Thank you very much.
We will request you to please introduce yourself to the listeners and tell us a little about yourself and your journey.
All right. Thank you so much. My name is Dr. Narendra Kumar Mehra. I actually belong to Amritsar, where I grew up, where I was born and grew up. I went to the school there, I went to the medical college there, and then I joined the All India Institute of Medical Sciences in 1969, July 1969. And I wanted to do the post-graduation over there. Now, during my post-graduation at AIIMS, New Delhi, this is in the early 70s, I went for a training course in immunology, which was being organized by the WHO in Singapore. Now, immunology at that time was just an upcoming specialty. Not much was known about that. The only thing that we knew about was that there are lymphocytes in the body which help to fight infection. And that's about all, because at that time you can imagine that the only tool that we had was a light microscope. We could only see the lymphocyte from the peripheral blood under the light microscope. We didn't have electron microscope, which came 10 years afterwards. Now, in that course in Singapore, which was about 3 months, and I think that drew me towards immunology even more, because we wanted to understand, because we could learn that all infections, everything that we sort of get exposed to the environment, what we call non-self, the concept of self and non-self. If there's something self that belongs to my body, the immune system does not normally react to it, but sometimes it does. But non-self, you are exposed to any viruses, any bacteria, fungi, any other foreign agent, which we call it as a microorganism. And you've seen that during COVID time also, the COVID and the immune system comes into play. So that was very exciting field at that time. But I was getting more drawn to the one particular component of immunology, and that's the transplant immunology. We were trying to exchange skin grafts between various strains of mice, trying to understand how does the immune system act when we put skin graft from a different strain of mouse. This is what we do in humans. And, one thing leads to the other and all that. So my thinking was becoming more into that particular field, transplant immunology, and this subject was totally absent in India at that time. I must tell you, in the mid-70s. Now, mid-70s was also the time when our surgeons at the institute and the nephrologists at AIIMS were very keen to start doing kidney transplantation. Because at that time, a lot of other centers around the world had started doing it. Because we had understood, and there was discovery of what is called as the HLA system in man. And that is the human leukocyte antigen system. That system got developed due to a lot of efforts done in the last 40 years or so. But then it was beginning to be understood that unless you match for HLA antigens between the donor and the recipient, the graft that you put from somebody else may get lost. Like you match for the blood groups, for transfusing anybody with blood, you need to give A blood group to the A donor or to the AB donor. O can go to anybody and all that. So there are universal donors, and the blood group has to be matched when you want to give blood transfusion. But these blood groups are expressed on the surface of red blood cells or the erythrocytes. So this HLA system that came suddenly as a bolt from the blue, these are expressed on the nucleated cells. So you can say like lymphocytes and any other cell in the body that has a nucleus in it. By the way, I'm sure most of our listeners know that the red blood cells are non-nucleated cells. They don't have a nucleus inside. So that is why we say that the nucleated cells. The other thing that we learned over the years was whereas the blood group system is very narrow, for, as I said, 4 major blood groups. Of course, there are many other minor as well that we know. But the HLA system was very polymorphic, much more polymorphic than the blood group system. So you needed some effort to find a suitable donor if you were to take the organ from a random population. But that came later. At that particular point of time, we were only taking organs, maybe kidney or liver or heart, for transplantation into somebody whose own organs are not doing well by matching with the HLA system, HLA antigens. Because it turned out from various centers around the world that the better the match grade of HLA antigens between the donor and the recipient, the longer is the possibility of a survival of the graft. So that became very clear. Also, it was very clear that there, in addition to the matching, the donor recipient matching for HLA, by the way, we also have to match for blood groups as well. We cannot give kidney to somebody who is blood group mismatched. Although we are now doing a number of ABO incompatible transplants as well, then the recipient has to undergo certain formalities and all that to make sure that the erythrocyte antibodies do not act. But in kidney transplant and in any other organ transplant, problem was not only the matching of the donor recipient but the development of antibodies. There are antibodies that the recipient develops, and sometimes these are directed against the donor antigens. So the kidney graft that you got, the recipient immune system will raise antibodies against that organ there, and the organ can get lost. So we have to not only match for this, but also look for the antibodies. I'm trying to make this discussion very simple for the sake of everybody. The things are not as simple as I am saying because there are lots of tests that we do in the laboratory at the pre-transplant stage. And this system developed in the 70s and the 80s and 90s. And today, oh my God, the possibility that theoretically my HLA system will be similar to that of yours if I need to match for, if I need a kidney graft from somebody from outside of my family, the theoretical chances are 1 in 10 billion. So that's the level of diversity that we have of the HLA system as compared to the ABO blood group system there. that is why this science grew. And I was the first one in India to establish an independent department of transplant immunology and clinical immunogenetics at the All India Institute of Medical Sciences, New Delhi. So you can see how I diverted. I came from Amritsar. I had very little idea. In the early 70s, everybody thought that AIMS is something, unique. It is even now very unique. But what was being discussed, and even now, that the admission to any degree course in AIMS is an uphill task. Even now it is an uphill task. But I'm talking of those, even during those days and all that. So I was feeling very lucky, very fortunate to have entered the portals of the AIMS New Delhi. And I found this institution very competitive. Everybody that we have in the institute had really something or the other to do new, compared to anybody else in India. Our comparisons, our competitions used to be with the international scientists, and that actually helps you to do what is called the cutting edge science. So each of the members of the faculty, I'm not saying me alone, but several are engaged in cutting edge science in the institute, and that is why you can see even today or today, institutes stand tall in the field of medical sciences. It's well known and well recognized all over the world. Of course, when I decided that I want to stay in this field, I needed some training. I had no training. For doing HLA typing in the early 70s, I just went to the library and took some journals and saw that you can really write to the National Institutes of Health in the US to ask for some reagents from them. But I needed an inverted phase contrast microscope. I didn't have that. I needed a microsyringe. I don't know from where I got, whether I stole from somewhere. But I had that fire in the belly that I must do something in this particular field, even if there is nobody to train in India. And at that time, there was nobody to train. So, what happened? Shall I tell you a little story?
Yes, sir, sure.
It's a very important story. So, as I'm saying, that the HLA system was developed primarily because of the need for an organ transplant. And that was our need. That is how there are three scientists who were then given Nobel Prize. And the Nobel Prize was given in 1980. One was the French scientist, Jean Dosset, and the two were the American scientists. And while the French scientists work in the human system, the two American scientists were working in the mouse system. Because mouse is a wonderful sort of animal system for us to understand the immune system. So 1980, and I'm talking here of 1974-75. But what happened was that in 1973, one doctor in UK stunned the whole world when he showed that patients with ankylosing spondylitis, ankylosing spondylitis is a patient who has a bamboo spine. You would have seen that they cannot bend. They have a typical gait. They don't walk the normal gait that we have because the spine is fixed. But what he found was, at the time, the tools that we had, they were very bare minimum tools. We were doing a serology-based test. Now nobody does a serology-based test for HLA typing. But the serology-based test was the main test in the 80s and 90s. And in the 90s, of course, the whole thing changed. And he showed that there was a gene called HLA B27. The B27 gene was found in a study in almost every case that is diagnosed as a patient of ankylosing spondylitis. So he showed to the world, look, HLA system is not just primarily for donor selection for organ transplantation, but it could be used as a fantastic diagnostic marker. And that every patient, so everybody around the world was now doing HLA-B27 typing, and they confirmed everywhere, yes, we are right. So we also did. We also started working in this 1976-77. One of my colleagues in the Department of Medicine, who had special interest in spondylitis. Now, of course, this is being done by the bunch of specialized doctors called rheumatologists. It's a rheumatologist's viewpoint, and we were also doing our studies, and we found yes, in India also there is a very strong association of HLA-B27 with ankylosing spondylitis. So these two streams were now developing parallel at the same time. Somebody working in the diseases, trying to work on every disease and see if there is a biomarker, if there is a marker over there, some HLA gene is associated. And the other side was we were working on the transplant field. Now, in the mid-70s, as I said, there was a lot of interest in AIIMS to start kidney transplant. I was a young man. I of course joined the faculty of the institute only in 1979. So from 75 to 79, I was wandering around everywhere. I went to Europe many times, and I'll tell you how. And of course, I was a postdoc fellow here, and but trying to look for a job, and then ultimately the All India Institute of Medical Sciences created a special job for me, faculty job, to establish this subject, and we then later on named it as the Department of Transplant Immunology and Immunogenetics, the first very department established in India, and even now it is functioning. Although I retired way back in 2014 end. But there are students of mine all over India. Almost everybody in India who does HLA typing now has been either a direct student of mine, or student of a student, or has undergone training under me in one way or the other. Now, because of this association with HLA-B27, and I'm continuing my story now, we wanted to do similar studies in leprosy. I may inform the audience that in the early 70s, leprosy was the most prevalent infection in India. Out of the 10 to 12 million cases of leprosy that we knew all over the world, 5 to 7 million were in India. And everybody was looking at the scientists in India, at the doctors in India, particularly those in AIIMS Delhi, that you have to find a solution to that. So when Bruton in 1973 showed that there is a very strong marker for ankylosing spondylitis in the HLA system, we thought, why not do in leprosy as well? So my boss at the time, who's no more now, he had some contacts with Nagpur and that place called Wardha. I'm sure everybody knows where Wardha is, very close to Sevagram, where Gandhiji spent significant part of his life in later years. Why we chose to go to Wardha? Because Wardha was a highly endemic area. And I remember the first time I went there in the train in 1974, we went to the villages around Wardha. Oh my God, we were stunned to see almost every household in this village had 1 or 2 cases of leprosy. Now, I didn't have, as I said, I didn't have a microscope. I didn't have the kind of microscope that I required for my studies. I only had a monocular microscope where you can see it from the top. But you need to have the conviction, the fire in the belly. And I keep saying to my students, it is very important. If you want to become a good scientist, you must have a fire in the belly. So the fire in the belly, I started doing with whatever minimal gadgets that I had. did some studies, as I said, by asking the NIH Serum Bank in USA to please send me the reagents, and they were very kind. They immediately sent it. Of course, it takes you those days. It used to take you 2, 3 months, 4 months. You write in the letter, and the answer comes, and then the packet comes, and all those kind of stuff. I don't have to go into details of that. So we did that study, and my paper, and I published that study in 1975 in a journal called Tissue Antigens, which was, and even today, was the topmost journal in the field of HLA. And that paper must have caught eye. That paper was entitled HLA and Leprosy in India. That paper must have caught eye of some of the stalwarts all over the world. And the guy who ultimately got Nobel Prize in 1980, the French guy, Joseph, he was doing the first international symposium on HLA and disease in Paris in 1976, in June 1976. And he invited me to come over there. Of course, the letters take a lot of time. I don't know how. He must have seen my address from the paper that I published, and I got the invitation to come there. You must attend this, because they had thought there is at least somebody from the developing world who is doing HLA practice. They were actually surprised when I met some of these stalwarts. They said we were surprised to see somebody over there. So I went to Paris. I don't know how I organized the travel money, but I must say I traveled by the cheapest airline, and had no idea where am I going, because unlike today, you didn't have that social media and all that. You didn't have any. I mean, there's no understanding how Paris looks like, except that my close relatives and friends will say, "Oh, you're going to Paris? Paris has roads of glass." I mean, they meant that they were very clean and all. Anyway, I did go to that international symposium, and that opened my eyes. I could never believe that a convention center could be as big as I saw at that time in 1976. But I must have stayed in a very cheap place, very near to Gare du Nord, which is the north end station in Paris. Like we have our guest houses or small hotels near our railway stations. So that was like that only. And I do remember I reached there on 22nd June 1976. It was very hot. If Delhi was hot, Paris was hotter. I couldn't believe. I thought Paris would be colder. Anyway, I had a cheaper room on the 4th floor, and I didn't know at that time that you had to travel light. I must have taken a good amount of bags with me, and I had to carry it myself to the 4th floor. By the time I reached there, I was totally wet. I looked at the room, there was no fan. There's no fan in SEU Europe. But the heat was, I would say, even more than what I was experiencing in Delhi at that time. But that's besides the point. But I mean, went to this conference. I put up my poster there of HLA and leprosy in India. And this is a Dutch guy who came to me. He was a Dutch student. He was a few years elder to me, of course. But, of course he belonged, and he was from Holland, Netherlands. And they had also done leprosy studies, HLA-based leprosy studies from patients that they got from Suriname. Suriname, as you know, is a Dutch colony, right? So, and that study that they had done, I went there to see, went there to try and understand the study. I couldn't understand it much. But this guy comes to me and tells me, my boss will come tomorrow to meet you. So be here at about so and so time. And this boss of his was Jan van Rood, Professor Jan van Rood, who was also at that time being talked about as a possible contender or a possible strong contender for the Nobel Prize. So, I was very scared, and I must say that night I did not sleep for a minute because next day I had to meet Jan van Roodt. So Jan van Roodt came to my poster and he asked me, "Is this study done by you in India?" I said, "Yes." He said, "Done totally by you?" I said, "Yes." So first, I thought I should hide my weaknesses. Then something spoke to me in my mind inside, "No, you must be truthful to this man. He's too big a man." And I was at the time thinking of finding a place either in Europe or in the US where I could go and spend a few years over there, so that get further training and all. But this man tells me, "Oh, fantastic study, very nice. That's the way to speak to you anyway." So I was trembling in my legs and I said, "Sir, I don't know whether what I've done is right or wrong. Nobody has trained me. There's no training for me. I just read from the journals and I've done this study. But this study is published in a journal. And I don't know whether the calculations that I've done are correct or not." So I think this must have impressed him, the straightforward truthfulness of somebody. So he told me, "We have done similar studies in leprosy from Suriname." I said, "Yes, I went to see the paper, but I could not understand it much. It was family studies and didn't understand much." So he said, the next sentence was, "Would you like to collaborate with us?" Now that was something surprising. Coming from such a big man to collaborate. I was looking to be a student, a postdoc student in his lab or something. But he said, "Collaborate." He said, "I'll come over to India and all that." And from there the story started. And in fact, he took me from Paris to Leiden in Holland. He said, "No, you don't go back to India right now. You come with us to Leiden." And he said that and went away. And I told his students, "Look, my dear, I have bought a very cheap ticket. I have to go back. If I go to Holland now with you guys, how will I go back to India?" So they said, "Oh, don't worry. Once Jan says like this, you just don't worry. Everything will be done." So I went there to Holland 2-3 days and discussed and all that. The kind of laboratories I saw, I had never seen in my life. This was a great trip for me, opening my eyes everywhere. And of course, we then got some grant. Jan van Roodt and his team came to India. He took them to Wardha. Jan was very fond of Gandhiji. He went to Sevagram and even sat over there in Sevagram and even kapas, cotton. He sort of made the cotton as well over there. So. And from there on, there was no looking back for me. We published very important papers in leprosy. Together, I went to Holland. In the next 10 years, Holland almost became like my second home. I was being invited by them every summer to come over there and do 1 or 2 months of stay and training and some studies. It was a remarkable experience, and then I was getting a little more known in other parts of the world, so there was not a part of the world that I never been to. In 1986, I even went and spent 2 years' time at the world-famous Fred Hutchinson Cancer Center in Seattle, USA, where rather than organ transplant, they were doing more of bone marrow transplant. Which is now called as the hematopoietic stem cell transplantation for patients with various types of cancer. So that was the other exposure I really acquired, so that was great. And from then on, all various awards and almost all the highest awards for science that India has, I got all of them. I received the Bhatnagar Award, the SS Bhatnagar Award when I was only 40 or 41, and after that every other award, and got known internationally, fellowship of various academies, within India and outside. I got the fellowship of the Hungarian Academy of Sciences, the French president, the French government awarded me the Cavalier of the National Order of Merit. Iranian research organization gave me their highest award. And now of course the International Science Council or the Royal College of Physicians of UK. I mean, it is unending list of awards that I got. And I'm only telling this that you have to be very sincere to the studies that you do, to the work that you do. You need to be dedicated to your patients. You need to be dedicated because this specialty was beginning to, I had to establish for the first time in India. I had to not only give clinical service for selection of donors for transplant, but also do education, training. A lot of PhD students were trained, a lot of MD students were trained. So that has been my brief, the history.
Thank you, sir. Thank you so much. And it was a lovely story. We could get to know about you in so much of a depth. And since you have spent a bigger portion of your life at INSA, so we would request you to tell us about your journey at INSA. Your role had been at the apex of the institution. You had represented INSA as a vice president. So tell us about how did you join INSA, how was your journey and your contribution?
As an academician, the biggest recognition of academician comes not only by your peers all over the world, not only within India and outside, or you get some scientific awards, but the academies like this start to recognize you. So I first became fellow of the Indian National Science Academy, I think way back in 2007 or so. And you have to apply for it, and it's not very easy to become a fellow. You get a title of FNA, you are a fellow of the Indian National Science Academy. Similarly, there are two other science academies in India, and I've been a fellow of them. There is an separate academy of the medical sciences, the National Academy of Medical Sciences. So I became fellow of almost all of those academies, and as I said, even the Hungarian Academy of Sciences. So, during COVID time, of course, G20. The G20 has several components. One of the components is the Science 20, S20 as we call. The Science 20 is organized by the Science Academy of the country there. So in 2019, we were chair of 2023. We were the G20 was done in India 2023. 22 was done in Indonesia, 21 in Italy, and 2020 was in Saudi Arabia. Now, because of my international connections, as I said, I got to have traveled almost all parts of the world and contacted. This world is spread around. I'm an international traveler. So when G20 came in 2020, I got a call from the Indian National Science Academy that we have to take part in the Science 20 that is being organized by Saudi Arabia, and we want you to take part in that. So we were doing it online because of the COVID. So that's the first time that I took part in the Science 20, and I was beginning to understand what this is actually about. And 21, there of course was in Italy, where the theme was totally on COVID infection, and 22 again was over there in Indonesia. In 2022 January, then Indian National Science Academy and the Council in 2021, the Council had decided to elect me as the Vice President for International Affairs. The Indian National Science Academy, INSA, has 6 Vice Presidents there who help the President of the Academy. in various ways. So I had the task of international affairs. So we and that was the year when we were doing the Science 20, and INSA was given the charge for that to do the Science 20. We organized, we took up the theme, transformative science for sustainable development, and with three sub-themes, like the clean energy for greener future, universal holistic health, and connecting science to society. All of these are actually connecting science to society. And so I joined as Vice President International Affairs in 2020 and 2022 for a 3-year term. So I just finished my 3-year term just a month ago. And during this 3-year term has been a very, very, enriching experience. I learned so much about science policy, so much about science diplomacy, and interacting with other science academies around the world and all. But by the way, let me give you a little bit of information about the Indian National Science Academy, for the sake of our listeners there. Indian National Science Academy, and the short we call it as INSA. It is located at the Bahadur Shah campus of Marg. It's a very imposing building, the red building that we have. And this academy was established in 1935. And the primary goal of establishing the academy was to promote science in India and applying scientific knowledge for the benefit of humanity and for the benefit of the nation. It was actually inaugurated in Calcutta and later it moved to Delhi. Originally it was known as the National Institute of Sciences of India, NISI, and later the name was changed. The academy was influenced by the work carried out by the Indian Science Congress Association. And the Indian Science Congress Association headquarters are in Kolkata. The Government of India, of course, sought input from various organizations before forming a national research council, and that Indian Science Congress Association played a very key role in advocating the creation of the Indian Academy of Sciences, which then later became the Indian National Science Academy, and its headquarters moved to Delhi. The mission of INSA is to act as a resource pool of knowledge. And how do we do that? The resource pool of knowledge is done by electing top scientists from India as fellows of the academy. Top scientists, it's a very uphill task. You have to go through a lot of committees and expert groups who must get convinced that you are good enough, or you have contributed in your particular field good enough amount of work that you can now become a fellow of the Indian National Science Academy, and you would also be engaged in promoting science in India, harnessing scientific knowledge for the national welfare, and nurture scientific talent in the country. And of course, identify and nurture scientific talent in the country. So that is a very important part. By the way, as I said, there are 3 science academies in India. INSA is in Delhi. There is the National Academy of Sciences of India, which is in Prayagraj, earlier called Allahabad. And there is the Indian Academy of Sciences in Bangalore as well. So the INSA is the adhering international academy from India, which means for international science academies that we have, they only recognize INSA as the scientific academy from India. And this academy looks into all sciences, it's not just the physics, chemistry, mathematics, space research, life sciences, even health sciences, biochemistry and things of that sort. All sciences that you have are actually covered under the domain. So and to cover that, we have various committees made, the national committees. The committees are the ones which will then elect fellows and all that. So the vision of INSA has been to develop as a vibrant, globally competitive scientific community accountable to the society and support impactful science, aligning with the national goals and create interdisciplinary synergies. So the job of the fellows who get elected is not just that you get a title of a FNA, but you must continue to do this kind of work, as I said, and establish forums for the scientific community to provide policy inputs. This is very important, policy inputs on societal issues that involve science and technology. And another vision is to develop intellectual infrastructure for meaningful interaction between scientists, public administrators, and practitioners to inform policy. So these are and collaborate with broader scientific community within India and outside to achieve common goals and enhance understanding and engagement with science and scientific developments. So another goal is to make sure that the science percolates to the society. So we do call from time to time students from schools and colleges and do some kind of activities over there so that they understand what the role of INSA. And if you go to the website of INSA, you will see several objectives that we have placed. And these objectives are all to revolve around on the goals that I already talked about, the vision that I've already talked about. One of the things that INSA does is INSA must make sure that our fellows work towards excellence in science. And for excellence in science, the scientists must aspire to become fellow. If you are a good scientist, you must aspire to become a fellow, because once you get recognized by your peers that you are good enough to be a fellow, that gives you a lot of kick. That tells you that you must be doing something good. Otherwise, you may be doing anything in your own domain, and the people don't recognize your work, And so the INSA fellowship is given for recognizing, nurturing, and promoting talent in science, and this is one of the major activities of INSA. And I must say that the fellowship of INSA is a highly coveted honor for any scientist in India, because the scientists can now write all the degrees, the PhDs or whatever, or MD or BM, and then at the back FNA. You put FNA or you put other academies, fellowships, the acronym, people then recognize you that you must be a very good scientist in your own field. So we have about 12, as I said, sectional committees. From mathematical sciences to physics, chemistry, earth and environmental sciences, engineering and technology, general biology, molecular and cell biology, biomolecular, structural biology and drug discovery. Health sciences is separate, even though there is a National Academy of Medical Sciences which is only for health sciences, but health sciences also appears in INSA as well. So there's one section dealing with health sciences, and that is how I became fellow in the health sciences field. And then there are sections made on agricultural sciences. In the last 2 years, and since Professor Ashutosh Sharma, that he was the Secretary of the Department of Science and Technology, is a very important scientist from the IIT Kanpur. He got elected as the president of INSA in January of 2023, And since during this time we have added two new categories to these sections that I already talked to you. One is science in translation. So his idea was that we must also make fellows somebody who may not have taken up these well-defined subjects in life, but doing a lot of work for helping or nurturing science in India. The other section that we added was this science for society. So science in translation and science for society was added in 2023, and last year we started taking fellows under those two categories as well. So in addition to this, at this point of time, we have over 1,000 Indian scientists as fellows of the Indian National Science Academy. That's not a very large number, looking at the size of the country, and of course the number of institutions and universities have grown exponentially during the last few years. We need to revise that number, but earlier the number used to be very small. Now we decided to at least take our upper limit to take about 100 scientists as fellows every year. Whether we achieve that number or not, but at least 50 to 60 are definitely being taken. In my time when I became fellow, it was only about 20 to 25. So now we increased that domain to make sure that we don't leave out anybody who is good enough. After all, it gives encouragement to these scientists. In addition to Indian scientists becoming fellows of INSA, we also have INSA Foreign Fellowship. So scientists from other countries who play a substantial role in the development of Indian science are also elected as INSA Foreign Fellows. So a foreign scientist could be any part of the world, must be good, but he has also contributed directly or indirectly in promoting science in India, and the committee sits down and evaluates the CV of that particular scientist and also includes them. By the way, I also got elected just last year. I got elected as a fellow of the Science Academy in South Africa. So South Africa is the second country of which fellowship I am being given. The first, as I said, was Hungary. I'm a fellow of the Hungarian Academy of Sciences. I'm also a fellow of the South African Academy of Sciences. So likewise, we also in INSA, we also induct foreign fellows as well. In addition to the fellows, we also encourage young scientists. So we have the INSA Young Scientists, and we have actually created the Indian National Young Academy of Sciences, INIAS, that gets directly grant from INSA. Here we promote scientists below 40 years of age. They can become INSA Young associates, IYA, and these are people below 40 years of age. We take about 20 every year. So any citizen of India below the age of 40, but there is a 3 years relaxation for women scientists, is eligible for nomination as the INSA Young Associate. Then last year, this was Dr. Ashutosh Sharma thought that there are a lot of people, because, generally a fellow becomes when he is about 60 years of age, because you must do substantial amount of work in your life. Science is not that easy. Taking a career in science is not easy. So I therefore keep saying anybody who wants to be a scientist must feel in his or her mind, commitment to science, and my commitment is towards advancement of knowledge in science and in technology, all for the benefit of the humanity. And only those people should come up in science. So we had that sizable number of people who are between 40 to 50 years of age. So for them, we since last year created another sort of opening, calling them as INSA Associate Fellows. So we have started taking associate fellows, which are people below 50 years of age, and they are eligible to become INSA associate fellow as well. So there are various ways that we keep trying ways and means of encouraging our science and scientists in India. INSA also deals in excellence in science, so we have various activities. We elect people for INSA distinguished lecture fellows. Somebody is really great, we sort of do that. Another focus of INSA is on National Commission for History of Science. History of science and history of technology in India, these are very important subjects. Normally, most of the young scientists don't look into this. But for doing good science, it is very important that you understand the history. The history guides you for your future work. So this INSA History of Science Young Associates, we started in 2023 to recognize young scholars of extraordinary promise and creativity who have made notable research contributions in areas related to the history of science. And of course, INSA also publishes a lot of books, publishes a lot of journals. We have a very famous journal called the Proceedings of the International Science Academy. We have the Indian Journal of Pure and Applied Mathematics and the Indian Journal of History of Science and the newsletter. So these are some of the activities that we keep doing in terms of publications and all. And if you look at the website of INSA, there are a lot of books. I also wrote a book during COVID time. I was asked by the council in INSA to, during that when COVID came, I was encouraged, I should say, by my children, my daughter and my son, who said, "Dad, you wrote so many publications, scientific publications all your life. Why don't you now write for the common man? So write for the newspapers on the topic of host immunity and vaccines." And I wrote about 20 articles at that time. My article was coming every month in Hindustan Times on educating the common man on immune system, how does the immune system, how does the COVID virus, and removing doubts of the common man, and what kind of vaccines are on the horizon, what can the vaccine do. That was a great experience. In 2020 and 2021, part of 2022, I think this was fantastic time. Of course, we were going through a very difficult time. The whole world was going through a very difficult time of COVID, and we didn't know. There was a time when we didn't know where are we going. Are we ever going to get out of it, or will the humanity be vanished?
Yes, thank you so much, sir. We had another eminent scientist, and I'm very, very proud when I could speak to sir. Until and up to when we meet with another enriching talk in Vigyan Ki Awaaz, please take care of yourself and stay tuned. Thank you. Dear listeners, we take a break at this enriching conversation. In the next part of this episode, catch more insightful discussions about science and the world of science. In the next episode, we shall bring to you more interesting discussions, his colorful contributions in the field of science and his passion for the field. Until and up to we meet in the next episode, please take care of yourself, stay healthy, and keep listening to Vigyan Ki Awaaz. Vigyan Ki Awaaz, a podcast series to popularize STEM, science, technology, engineering, mathematics, and medicine.